So in the first video, we talked about the stationary phase and the mobile phase. What we're going to look at now are more specifically 5 different types of chromatography, so more details on how this happens. So these are the 5 types. We're going to go through them one at a time. So starting at adsorption chromatography. Adsorption chromatography is when the solute, the mixture, is adsorbed, so attached to the outside of the surface of the stationary phase. Okay. And exactly what I talked about with the thin layer chromatography and the column chromatography in the last video, that those are both examples of adsorption chromatography. So the stationary phase is a solid and the mobile phase is a liquid or a gas. And the compounds, the mixture, and then the components inside the mixture are going to be strongly attracted or more strongly attracted based on intermolecular forces to either the stationary phase or the mobile phase. And so that's what's going to allow those components to separate. So TLC is one example of this. So it's all about the relationship between the solid stationary phase, the solute, and the mobile phase, which is either a liquid or a gas. So this is the picture the textbook gives us on this. I'm not sure why. So the blue squiggly thing with the fingers is supposed to be the stationary phase. And then the gray dots are supposed to be our samples. And then the mobile phase would just be, kind of moving down through this. They don't have a picture for it, kind of like think of the white would be like the mobile phase. So that's adsorption chromatography. And again, that's the one that you probably have the experience with. Oh, and I should mention as we go through this with the types of chromatography, what you're going to be expected to know in general how it works. So adsorption chromatography, it's about the intermolecular forces, how much it's adsorbed to the surface, and know that the states of matter of the stationary and the mobile phases. So the stationary phase in adsorption is always a solid, and the mobile phase is either a liquid or a gas. I'd be able to describe what's happening. You wouldn't have to draw this picture, but be able to describe it. Okay. Second type of chromatography is called partition chromatography. In this one, what we're looking at, it's like if we took a cylinder and then we chopped it and we're looking down it. So it's like we have a pipe, but we're looking down into the pipe is what we're looking at here. So in this situation, the stationary phase is liquid, but it's really a viscous kind of like gel type of liquid. So in this picture, that's the light blue ring that's right here. The gray ring outside of it is like the metal of the pipe, the container that it's in. So that's the metal container. It doesn't have to be metal, but I'm going to say it's metal. Wow, look at that handwriting. This is the stationary phase. So the blue ring is the stationary phase. The mobile phase is going to be a gas. And the white stuff in the center, so like the gray dots are once again the sample. So these are all like the molecules in there. The white is, well, empty space. It's hollow in the center. And so that's why the gas is the mobile phase. So what's happening is that the sample actually dissolves in the stationary phase. So it doesn't just stick to the outside, it actually dissolves in it. And then it slowly kind of works its way down. So in this one, it's truly more about the relationship between the stationary phase and the molecule. The mobile phase is just kind of putting pressure on it to force the molecules to continue moving. But as it's a gas, we don't see a lot of intermolecular force attractions with this. So partition chromatography is different than adsorption chromatography. Adsorption chromatography, there's no dissolving. The stationary phase is a solid. The solute sticks to the outside of it and slowly kind of travels down it. In partition chromatography, we have a hollow center. The stationary phase is a viscous liquid, so it's not like it's sticking. So like I think of it more like a gel, but it's not a solid. Okay, so it's a gel. And the gas is the mobile phase, and it's just putting pressure on it. And so with this one, you can see that like all of the samples that are out here in the middle, what's going to happen is they're just going to get shoved straight out like quickly. And so we need to have a very small concentration of our sample when we do it this way because there's only so much solution. In adsorption chromatography, it's a packed column. So like think like the sand in a burette, like it's just full of stationary phase. With this one, we have much less stationary phase. Okay. So partition chromatography. Thick, viscous gel, liquid, stationary phase, gas, mobile phase. And then the sample actually dissolves in the stationary phase and it's hollow in the center. Excuse me. Okay, third. Ion exchange. This one, this type of chromatography is only useful for ions. So if we have a molecular compound, so we're talking organic chemicals, that doesn't work for ion exchange most of the time. So in this situation, there is a stationary phase, and that stationary phase is going to be built to attract either cations or anions. So like the stationary phase is going to be covered in either cations or anions, and it's going to be a solid. And so what's going to happen is when we have our mixture, which is going to be a mixture of ions. So again, we're going to have cations and anions in that. The ions that are present in the mixture that are the opposite charge of the stationary phase. So the stationary phase could either be positive or the stationary phase could be negative. But let's say the stationary phase was negative, then the positive ions are going to be attracted to it. And so then that means all the negative ions are just going to whoosh, go straight through with the mobile phase. They're not going to be attracted to the stationary phase at all. And so we're going to then kind of attach all of those ions that we're looking at to it. The liquid is, or the mobile phase is a liquid. Okay. And so with ion exchange chromatography, we have the situation where those ions are going to be attracted to it, and they're not going to really move down the column quickly. Oh, shoot. Sorry. Okay. So they're not going to move down it quickly, so we might have to release those ions later. So ion exchange works for ions only. Solid stationary phase. The stationary phase is going to attract either cations or anions, not both, one or the other. The mobile phase is a liquid. The opposite charge of whatever it attracts, the stationary phase attracts, those ions will not be separated at all. Those will just be rinsed down through the bottom. The ions, the positive or negative, depending on which one it is, it does attract, will stick to the stationary phase. Okay, so again, works only for ions. Molecular exclusion, which is also called size exclusion. Size exclusion is a better term for it, but it's not the more common one. This one separates entirely based on size. So not about intermolecular forces, not about attractive, like positive, negative. So all of these so far have been about intermolecular forces to a certain extent, right? Either the adsorption where it sticks to the outside, but it still has these equilibrium reactions. The partition where it dissolves into the stationary phase, but it still has intermolecular attractions. Or the ion that is just straight up positive, negative. Okay, molecular exclusion is truly just based on size. So there is no attractive interaction between the stationary phase and the solute. Okay. The stationary phase is either a liquid, the stationary phase is a gel, but it's a porous gel. So that means it's got holes in it. The mobile phase is a liquid or a gas, depending on the situation. So what happens? These pores, these holes in the gel, are a specific size. And molecules that are larger than the holes, well, they can't fit through the gel. So what happens is they just kind of get shoved to the side and they move through without going through the pores because they can't fit within the pores. So the really large molecules, kind of like with ion exchange, where if the positive ions were attracted to the stationary phase, the negative ions just went straight on through. Okay. Well, molecules that are too large to enter the gel just go straight on through. They don't go through the gel. There's like a side, like a hallway next to the gel that it is able to just go down through the bottom without entering the gel. The molecules that are small enough to make it into the pores will then move through the pores, and then once they're in those pores, though, they will separate themselves based on size. The smaller molecules are going to move through this faster, and the larger molecules, like the molecules that are small enough to fit in the gel, but they're still bigger than the other ones, they move through slowly. So it's all about their size. Again, they're super large molecules. So here's the picture from the textbook, which to me is not particularly helpful, but whatever. The big ones, these are the ones that are too big to fit within the gel, so it just moves, they just go straight on down. Okay. The smaller dots fit within that. Okay. Now, again, these are pores, so think of it kind of like a maze. But the smaller molecules can move through that maze faster, and so they get through the stationary phase quicker, and so they're separating from the larger molecules. I guess I'll call them medium-sized molecules then. They were small enough to make it into the gel, but they're still big and clunky, and so it takes them longer to get through it. So this is based entirely on size. Um, and for whatever reason, the example, for those of you that have taken biology, I cannot think of the name of it right now, and that's going to drive me nuts. Um, use gels, like you use the term gels. Oh my gosh. Anyway, when it comes to me, I'll say it, but this is driving me nuts. I should have put it on the slide. I just always said, oh, I'll remember. Anyway, last type is affinity chromatography. This one is super specific. This is when the chromatography situation is for one solute. So it's not like where the ion exchange is like for positives. That seems pretty specific. This is like for calcium or something. Like, I mean, ridiculously specific. So that's why it's so selective. It's for interactions between one type of solute. And so that way the molecules that are involved are specific to that solute. Okay. So this is used a lot more common in biology with things like proteins. Okay. So if we have a molecule that could be an antibody to a specific protein, but not to other proteins. Okay. So all of the other proteins, so like the stationary phase would be set up with this antibody that only works for one protein. And then we pour in this mixture of a crap ton of proteins. Well, all the proteins that it's not an antibody for will just move right on through. And then the one protein or that it is an antibody for will stick to the column, the stationary phase. Okay, so it's going to likely be a solid. Okay, but then it's stuck there. And so what's going to happen is we have to then find a way to dislodge it because it's, we like trapped it there. So usually it's something like if you change the pH, that'll let that go. But what we're doing is we're basically separating a giant mixture down to just one component of that mixture. We don't care about the rest of the components. We care about just the one. So the other types of chromatography let us, identify the different components. So there are 4 different things in this mixture. And here's how they all handled the situation. Well, affinity is really truly just for one. Okay. So here's the picture from the textbook for that, which again, I mean, it looks to me like monsters, but this is supposed to be the protein that is the only protein. If you look at the shapes, it's the only one that will stick to the stationary phase. And all of the other ones are all different shapes, so they just move on through. So the stationary phase is a solid, and the mobile phase is often a liquid for this. So these are the 5 types of chromatography. Yes, there's a lot more detail that exists in the world. This is as far as we're going to go with these types of chromatography.